Hey guys, in this new Corona QuickTip tutorial we're gonna take a look at how to utilize improved Corona anisotropy in Corona release 1.3. So what has changed since the last release was that anisotropy now by default follows the local space of the object. It's no longer world space based, and optionally you can set anisotropy to be UV space based as well. So we're gonna take a look at how to enable anisotropy and how to use it in a local space first. So to see our effect, we're gonna create some metallic material, and for anisotropy to work properly, you need to have some amount of glossiness on your objects. If I increase the anisotropy, positive means horizontal or just one direction, negative means another direction. If I change it like this, you can see it does nothing as long as we do not have any glossiness amount. If we have a glossiness amount that's 1.0, meaning complete mirror. So well, let's just introduce some glossiness to our object. And now when I start to increase the anisotropy, you can see how positive values are stretching the highlight vertically. So we can go to the extreme values, but again, keep in mind, the more extreme the value is, the more difficult it is to sample the reflection. So keep this in mind. It may come with some performance penalty. So if we go lower to the negative values, you can see the reflection now stretches horizontally. And again, you can also just put it in a positive value, and you can rotate the highlight using this rotation parameter. Keep in mind this parameter is in degrees, so to rotate the reflection 90 degrees, you actually have to input quite a large number, 90 degrees in there to rotate the highlight. So you can see right now as I'm changing this, the highlight is rotating. So let's put it back, and if I go ahead and I start rotating the sphere, you can see the anisotropy is rotating with it. Let's say we have some more complex object. Let's say, I don't know, like let's create a teapot for now. Increase the subdivisions, get rid of the sphere, put our material on the teapot. And let's say we want our anisotropy to be stretching along some different axes. So if we just rotate the teapot like this, you can see the anisotropy stretching follows the object. So in order to change the axis, we actually have to rotate the object in the sub-object mode. So if I rotate, let's set this like this. If I rotate the object now in the sub-object mode, you can see that as I am rotating the object, the anisotropic orientation remains the same. So if I now exit the sub-object mode and rotate the object back, you can see we have now the anisotropy stretched along the different axes. So this is how you basically change the axis of the anisotropy rotation. But the lot more useful mode of the anisotropy is UV based, and I'm gonna show this on a most typical object you would use anisotropy on, which is a cooking pot. Cooking pots, especially the stainless steel ones, usually have some distinct brushing on the surface, and this brushing also defines the stretching of the reflection, as there is this kind of microstructure that basically reflects the light along the structure and creates these stretched highlights. So in order for our UV based anisotropy to work properly, first of all, we need to have some sort of good UV layout on our object. So let's just put some material on this and put the checker on the diffuse. And if you increase it, you can see I have my object with quite nice UVs and we can start working with that. It's not gonna work if you have messed up UVs on your mesh. Another thing I did is that I expected that on the sides of the pot the brushing will be horizontal, but on the top and the bottom, or on the bottom part, the brushing should be radial. You see that those like circular reflections usually on the pot. So what I did is I assigned material ID1 to the edges and material ID2 to the bottom parts of our teapot of our cooking pot mesh. So with this done, I'm gonna use again. I'm gonna create just a new material. Let's call this a cooking pot. All right, and let's start creating this material. So again, reflection 0. For stainless steel, I would use something like this. And right now, I'm gonna just grab new Chrono multimap. We know that material ID2 is our bottom and material ID1 is our sides. So let's just go to the advanced options, and here we can switch anisotropic orientation to UVW. So this is what we're going to do. And right now, if I just take this and plug it into anisotropic rotation, let's set this to black first. Let's set this to black as well. You can see that as I start to change the value of our anisotropic rotation color, you can see how the reflection is kind of moving around, which is not. Oh, there we go. I forgot to actually enable the anisotropy. There. Now you can see the black is horizontal, and if we go to 64, that's perfectly vertical. If we go 128, then that's 180 degrees. So again, it's horizontal. If we go here, like 192, that's again vertical because that's 270 degrees, and white is again horizontal because it's 360 degrees, which is basically just the same as 0 degrees. So with this in mind, we're just gonna keep this at black, adjust our glossiness a little higher, or rather this actually looks good, so let's keep it this way. And for the material ID2, which is our bottom, we're gonna use a texture. So for the texture, we will use gradient ramp, which we will set the mode to spiral. Alright, once the mode is set to spiral, just connect it to the color slot 2, and you can already see some of that radial reflection showing up in the bottom. The problem is when you're using the linear workflow inside of 3ds Max, 3ds Max actually applies the gamma also on the procedural textures, and that's not always desired. So in this case, what we will have to do is to put color correction here and set the gamma of this texture to the inverse gamma correction. That means 0.455, and once we do that, we should get correct straight streaks of reflection. It shouldn't be bent as it was with the gamma with the gamma corrected texture. So if I set it to 1, you can see there's this distinct bending as if the bottom of the cooking pot was bulged, even though it's completely flat. So to get correct result, we need to inverse gamma correct it to get this. Okay, so now once we have this set up, the anisotropy on its own usually won't do. So the good practice to create a realistic anisotropic material is to combine them either with bump or glossiness mapping to get some more definition in the reflections. So for this, I'm just gonna duplicate our Corona multimap. I'm gonna plug it to the reflection glossiness, and here I'm gonna use first the horizontal brushing texture, which is just some texture I made in Photoshop, and as you can see, it's just texture of horizontal brushes. And I'm going to plug it in the color 1 and display it on our mesh as well. We can see the streaking, we can actually increase the tiling, and we will decrease the blur so we can see the small detail. And now I'm just gonna start to increase RGB level until we get our desired glossiness amount back. Okay, so as you can see, now we are getting both the reflection stretching as well as some distinct brushing texture. This may be too much, so I can just increase the RGB offset and decrease the RGB level slightly to get less contrast, like this. And now we're going to do the same thing also for the bottom of the cooking pot. So let's rotate it again so we can see the reflection inside. I'm gonna duplicate the texture. I'm gonna use the radial brush texture this time, which looks like this. And I'm going to put it in the color 2. I'm gonna set tiling back to 1 by 1 and preview it on our mesh. As you can see, it fits nicely. You can ignore this mapping because the texture is assigned only to the material ID 2. Material ID 1 is our previous texture, so it looks wrong in the viewport, but it's right in the render. And now again, I can repeat the same process of adjusting the reflection glossiness texture. But I think in this case, it looks quite nice by default. So I can just, rotate it maybe like this and look around our object. Maybe the glossiness here is too high. So let's play with that. Here. And as you can see, we get correct brushing direction both on the edges of the cooking pot as well as on the bottom of the cooking pot. So this is it for the Anisotropic tutorial. I hope you found it useful, and I'll see you next time. Goodbye.